fisheries where we are this morning. Where we are now, we are in a marine aquarium, whereby it's just a model of sea. The model of sea, as you know, as our fishery is getting finished in the sea, so we have to make sure we show the community, all the people, the concern of the sea. As you can see inside, we have live corals. We advise people accordingly not to step on the corals and any future which is in the sea. As you can see, everything here is live. So it's a model of sea. As you can see, we have marine fish and all sea organisms like starfish, as you can see there. We have sea cucumbers inside, but they are hidden in the rocks. As you can see on the far end there, you can see a live coral, which is just mushrooming. In here, to make our seas well, we in the aquarium, we make sure we take parameters like pH, salinities, and DOH. So we must see if the pH is high or the salinity is high, the water needs to be changed, so to maintain the life inside. And also inside we have the wave makers, which are just making the water to the animals, into the fish, to see that they are in life. And as we can go on, you can see more animals inside. So it's a model of a sea. When we preserve our seas like this, we make sure they are all will all for our fish, as we have so many kinds of fish.
My name is Peter Thuo, an attaché at Kmfri, and my supervisor is Gladys Moka. So we are in our air wet labs, and we are doing an experiment that has been running for the last 2.5 months. And in the experiment, we are trying to check on which feed does well in the tilapia. So we formulated several feeds. We have our blood meal, which we use the blood as the main protein content. Then we have the black soja meal, where we substituted the fish meal with the black soja fly larvae. We have the telablaria, where the telablaria was the main protein content, and we have the normal feed that is produced at Kmfri. So during that period, we have observed that the water clarity and the water parameters are best in the black soja fly larvae meal, but when it comes to the growth factor, the telablaria is the best, followed by the blood meal. So by the end of the experiment, we are supposed to write a report and recommend what should be done in the fish meal production, and produce a substitute for the fish meal, which has become problematic to the world.
My name is Maureen Mukami. I am a mariculture scientist at Kenya Marine and Fisheries Research Institute. My main interest is on Atimia pond farming, and where we are right now is an Atimia lab, and this is where we are going to install the Atimia seeds processing equipment. But currently, we are running some experiments here in the lab on Atimia production. Basically, we are doing laviculture tests, that is trying to test Atimia using different species to see how the growth is, how the survival is, and also to see if our Atimia that are being produced here in Kmfri are of high value or can grow the larvae, because we know that the challenge in fish farming currently is on the growing of larvae. So this is Atimia that has hatched. Let me give you some little bits of Atimia biology. Atimia is produced in the ponds and in the salt ponds, because it thrives so well in very high saline waters. And in Kenya, we produce it in the salt farms. You've heard of Ken Salt, you've heard of Crystalline, who are producing salt for consumption. That is where we produce the Atimia. We inoculate it or hatch and then put it in the salt ponds, and when Artemia becomes an adult on the 15th day, so it produces young ones, and Artemia can either produce young ones, like organisms that are moving, or cysts. And cysts means eggs. It's just the same word as eggs. It produces an egg with a very hard shell on the outer cover, because and this is, they produce them during different environments. When the environment is very harsh for Artemia, it produces a cyst, because now it knows I'm about to die, and I might die without offsprings. So the best thing is I leave the offsprings in a cyst, in a shell form, and then when the conditions are good, the cysts will hatch and my generation will continue.
My name is Shaban Nzano, a research scientist and also a member of the Artemia lab. Now, apart from producing Artemia, we also do some pilot breeding experiments in the Artemia lab. At the moment, we are piloting the breeding of the freshwater shrimp, Macrobranchium rude. Now, Macrobranchium rude supports a dry fish fisheries in Kmfri County, but over years, the catch rates in the world have greatly reduced, probably as a result of overfishing and also the effect of climate change. So the idea behind the breeding program that we are undertaking is, one, to see if we can introduce Macrobranchium rude as among the species cultured in aquaculture. And then the other reason behind the breeding is to try and see if we can enrich the world stocks with larvae that are produced in hatcheries.
I'm David Midumbi, Kmfri intern. So this is our feeding room, feed production room, where we make feeds. So at Kmfri, we ensure that the feed that we are taking to farmers are within the accepted standard, that are within the market range. We compete with commercial feeders, those who make feeds like Fugo and different suppliers. So we have to ensure that we use our ingredients are in good condition, whereby we have high protein content, we have the wheat with high carbohydrate content. So we ensure that we mix them in ratios. We use the Pearson square method to ensure that our proteins are within the range, our carbohydrates are also good, and then the binders are also in good condition. So after obtaining feeds from the feed room, we ensure that we spread the feed uniformly so that they are not disintegrate.
My name is Gladys Mwaka. I'm a research scientist at the Kenya Marine and Fisheries Research Institute. This is a Dabaso area where we installed our cage. This kind of cage is called floating cage. We have different types of cage. This is floating cage. We have fixed cage, and also we have the submerged cage. We have the submersible cage, and this cage is 12 by 4 and by 1.5 meters. So right now what we are doing is harvesting so that we start the other experiment as soon as possible. So we are going to remove all these fish that are here in the other compartment and the third compartment as well, so that next week when we come, we start another experiment. Right now we've stocked rabbit fish, we've stocked tilapia marine, that is marine tilapia fish, and also we are coming to stock sea cucumbers. We do source fish from the wild, and we put them here for 6 months. Then after those 6 months, the fish are always have grown for consuming, and after that we normally give this fish to communities, because they already have a restaurant just here where they normally take them and sell them to the tourists. About feeding, we normally take feeds from Kmfri and give it to them. The ones that we formulate at the station is whatever they are consuming. This net is used to protect predators, especially birds that come along. So when birds come here, they'll not have space to predate our fish that are inside there. So that is the reason as to why we normally put this net. The project was last year's PC target, and it started in 2020, the year 2020. It has been here for a year now, and the reason as to why we started this is to utilize the blue economy potential in coast, because we have a lot of land and it has not been utilized, especially at the coast. Right now we only have 2 cages at the coast, and this is the first one. The other one is at the north coast, and that's why we had to start this cage, so that we can utilize the potential of the blue economy sector.
Cages are enclosed facilities on the bottom and the sides of either wooden, mesh or net screens that are meant for rearing fish. They allow exchange of natural water through the sides and below the cage, that is in most cases. So a brief history of a cage. Cages were traditionally found in Japan at a place called Kmfri in 1851. At the Mekong River, that is where the cage fish birth was taken place. So it then went to Kmfri to Thailand in 1930s, and also in Indonesia in 1940s, and then according to FAO 2001 it came to Africa in 1988, and here in Kenya cage was established first in 2005, and currently it is practiced in most of the African countries like Ghana, Uganda, Zambia and Zimbabwe. So there are different types of cages, and the first one is the fixed cages. We have floating cages, we have submerged and submersible cages. The one that we are having here in Dabaso, this we could say is a floating cage. So coastal communities have vast opportunities for cage culture because of its huge untapped blue economy sector, and many types of water resources can be used, like the lakes, like the reservoirs, the strip pits, the streams and rivers which could otherwise not be harvested. And also it allows the use of the pond for sport fishing or the culture of other species. It's easy to install fast, and the fish inspection is also easier. But since the cage is meshed, the fishes inside have less chances of being attacked by predators. Worldwide, cage fish farming is booming in Asian countries like the Chinese, the Indonesia, the Philippines, and here in Kenya, in Kenyan coast, a lot of potential is untapped. From Kilifi all the way to Tana River, offshore areas have shown to have a huge potential compared to the near shore places, and we've seen that Kilifi has been shown to have huge potential compared to the other coastal counties before. So let's utilize the blue economy potential. Thank you so much.